Hello chemistry class, this is Mr. Ng with two sample problems on combined gas laws. Okay, so here we have a gas law problem where we have a gas at a pressure of 12 atm, 23 liters, and 200 kelvins. And then I'm going to raise the pressure to 14 atm, increase the temperature to 300 kelvins, and it wants the new volume. Step 1, let's convert to kelvins. It's already in kelvins, we're done. Step 2, the equation. Our equation is going to be PV over T is equal to PV over T. 1, 1, 1, 2, 2, 2. Step 3, let's find our variables. 12 atm, this must be a pressure because of atmospheres. Liters, this is a volume, volume 1. Kelvins is obviously a temperature, temperature 1. Here's another Kelvin, this must be temperature 2. It wants the volume, so again a question mark. And 14 atm, this must be pressure 2. So next we plug in. So plugging in, P1 is 12 atm. 12 atm times V1, which is 23 liters, divided by T1, which is 200 kelvins, is equal to P2, which is 14 atmospheres, times V2, which is, we don't know, it's going to be our variable to solve, divided by 300K. So for these problems, if you always cross multiply, you'll never go wrong. So just multiply them across. Here, this becomes 12 atm times 23 liters times 300K is equal to 14 atm times V2 times 200K. I find that a lot of us have been doing two things that are kind of lazy and kind of making you do a problem over and over again. Some of you just aren't writing this down. So please just take the time and write it out. It's way better than being confused for like 4 or 5 minutes and not solving it. So just write it down and get it done in like 30 seconds. And number two, when you get here, you're punching a whole bunch of stuff in. So I recommend, if you're not really good with the math or good with the calculator, let's just simplify. So if I simplify on this side, I'm just going to do 12 times 23 times 300, and I get 82800 atm LK, or these are the units, they're still there, right? This is going to be equal to 14 times 200, which is 2,800 atm K times V2. So now we only have one number to deal with, a whole bunch of little symbols, but don't worry about that. Now we just divide by 2800, 2800. So 82800 divided by 2800, and I got 29.6, which is the right answer. Notice that this is going to be ATMK, ATMK. These guys cancel out, ATMs cancel out, Ks cancel out. The only unit left is going to be liters, and it's going to be 29.6 liters. Good. That is the answer. That feels good. What did I do? I converted to kelvins, didn't need to. Equation right here, cross multiplied. This is where I've been finding a lot of us are making mistakes. So take the time, slow down. You're not being given like 30 problems. You're given like 6, you know? So take the time and just write it out, please. That way you won't need to do that thing where like you're so impatient you waste a lot of time. One more problem. Let's try again. Okay, let's do another one of these gas law problems. First thing to do is to check for kelvins. I have 50 degrees Celsius. So kelvins is found by adding 50 degrees Celsius to 273. This is clear, 273 plus 50. I got 323 degrees Celsius, kelvins. So here, let's cross this out. 323 kelvins. Fine, I converted the kelvins. Our equation once again is our combined gas law. PV over T is equal to PV over T 111,222. Done. Let's find our variables. Let's see, 29 liters must be a volume 1. 5 atm is a pressure 1. And then 323 must be temperature 1. And then what would the temperature be? So we want the temperature now. If I decrease the volume of the gas to 2.4 liters, this is volume 2. And the pressure to 3 atm, this must be pressure 2. Good. So found the variables. Let's plug in. When we plug in, P1 is 5 atms, 5 atmospheres, times V1. Our V1 is 2.9 liters, divided by T1. In this case, it's 323 kelvins, is equal to P2. Our P2 is 3 atmospheres. V2 is 2.4 liters over T2, which we don't know. Notice that T2 is in the denominator, in which case you must cross multiply. You must cross multiply, like how we did the last time. So that's pretty easy. Let's cross multiply and solve this thing. So if I cross multiply, this is T2 times 5 atmospheres times 2.9 liters is equal to 323 kelvins times 3 atmospheres times 2.4 liters. Not a bad idea to just simplify now. So 5 times 2.9, I got 14.5 latum liters atmospheres times T2 is equal to 323 times 3 times 2.4. I got 2,325.6 kATML. Divide both sides by 14.5 latum. That's liters atmospheres. Atmospheres cancel, liters cancel. The only unit left is kelvins. And if you do this math, divided by 14.5, you get 160 degrees kelvins. All right? T2 is equal to 160. Let's see, it's only 2 sig figs. So 160 is the best I can do. Kelvins. If you want to convert this to Celsius, you just subtract 273. Or negative 112 Celsius. All right, it's technically, if you do sig figs, negative 110 degrees Celsius, because it's two digits sig figs. But don't let that bother you. Just know to find the variables, plug them in, cross multiply, simplify, and solve. I hope that helps, guys. Good luck on your homework.